Well, hello everybody. In this occasion, we're gonna be doing another LeetCode challenge. This will be 2265. Count nodes equals to average of Subtree. This is a medium challenge, and the description says, given the root of a binary tree, return the number of nodes where the value of the node equals to the average of the values in its subtree. Note the average of n elements in the sum of n elements divided by n and rounded down to the nearest integer. Subtree of root is the tree consisting of root on all the descendants. They give us a few examples here, but I think it would be best to jump right into the drawing. So six. What we need to do is to for every node we need to return the average of every sub tree that has this element. So for every child of this element, we need to sum them up and find the average. So for the average of this node will be 8 plus 0 plus 1 plus 5 plus 6, and all up we divide it by 6 elements. So it will be the sum of everything divided by 6. And if this number is equals to the sum of everything, we count it as one that has the conditions. So this will be plus 1. For example, we need to traverse to 0, and 0 is the average of 0 divided by 1 is 0. So it's equal. So we count it. For this node will be 1 divided by 1 equals 1, and it counts because this is the same as this. Okay, but for 8 we have 8 plus 0 because it's a child, and plus 1 that is another child. This will be 9 divided by 3. Sorry, divided by 3 is equal to 3. So this cannot count. So let's jump to the code. And now let's copy this. Let's remove these comments. This. Okay, now return 0. First, we need to understand that we're gonna do a depth first search. So we're gonna just traverse first. We're gonna traverse all the way down, and then we're gonna go up. Okay. So let's do a function in here, and we're gonna do a public or private int. We're gonna return the count of nodes that satisfies this condition for each subtree, the first search. We're gonna need a tree node root, and for now let's leave it at that. We need what we need. We need, if the condition is the node is null, so if root equals null, we want to return 0. This will be the element that we are returning, and return count. We need to have a list of elements. It will be integer. And we're gonna add our value, al root.var. But first, we need to traverse the tree and know if and grab all the values from the node. So we're gonna do the same function. Sorry. Count plus the first search root dot left, and we need a list in here. So everyone will have their list, and they will append to this list. So we're gonna do list integer elements, and we're gonna append to this list. But when we call, we wanna create a new list. So with new array list. Sorry, we need a list for every subtree. So we're gonna have a list for the left and a list from the right, and then we're gonna grab those elements and sum to our element list. So this will be list integer left elements or left child equals new array list. We're gonna do the same from the right. Now we need to send this left child and the right child. And we now add it to our list. So elements dot are all left, and elements are all but with the right child. Now we have that, so we need to find an average if node equals to average. So for finding the average, we're gonna need a value of double average equals we're gonna have a reduce function, yes, for elements dot stream dot reduce. Wanna start from 0, a b a plus b, and this we're gonna divide it by our elements dot size. So this will be our average. We need to find if average equals to our node. So there will be root.val. We're gonna just count plus plus. And for this, we're gonna return dfs root and a new area list. I think that's it. We're gonna create our. Let's just test it in LeetCode. Let's run. We need to this node. We need to read this. So the average of n elements in the sum of the n elements divided by n rounded down. So we need to round down our average. So this would be math.floor this. So I think now it should work. Run, let's see. Okay, bust, submit. And that's it. So maybe not the best one, but I think it's pretty easy to understand and to have the basic concept of traversing the tree and how we are using a recursive function to traverse all the tree. So if you have any questions, you can put